Hi guys, so welcome to CALQ here. In today's video, we're going to perform static earthquake analysis for a 10-story building using CALQ Seismic. Okay, so we have here our reference manual, and let's go directly to table of contents. And so ito, 10-story building. So ito yung i-analyze natin. So a 35 meter building with an average height of 3.5 meter each floor has a weight of 4,000 kilonewton for each floor. And anyway, this is just an example, no? So it's a fictional project. Okay, so 4,000 kilonewton for each floor and 3,000 kilonewton for the rooftop. So the building is located in Makati City on buried in soil and soft rock, 7.5 kilometer from seismic source 8. The use of the building is to carry hazardous facilities. So the structural system of the building is special reinforced concrete moment resisting frame. SRC MRF performs static earthquake analysis using 2015 NECP code. So ito naman yung tabulated value for each height and weight per floor level. So therefore we have total height of 35 meter. And then also included in the reference manual is the conventional solution for that compliance with 2015 CP. So we have this conventional, and we have also calculated that one using CALQ Seismic, okay, which is also included in the reference manual of CALQ Seismic. Okay, so and i-solve natin to using CALQ Seismic. Okay, so let's open the application. Click on this icon, and then just log in. No? So, andito na tayo sa working space ng CALQ Seismic. So, we just need to click getting started. And actually, we can load example now. No? So, dito sa problem ko, meron akong 5 example. No? So, kaya dito sa CALQ Seismic, meron din akong 5 example. Okay? So, yung mga example na to is naka-base dito sa reference manual. Okay, so I'll just skip this one and start from scratch. So let's start with earthquake seismic parameters. So provide earthquake parameter as follow. Again, we can click on this folder icon to learn more about total seismic. And we have the total seismic now. No? So solve natin. We have 3,000 plus 4,000 times ilan to? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, no? Hanggang 9. Hindi kasali yung sa conversion. Okay, so just type 9. So we have 39,000. So let's type that one here. So yung building height, we have 35. Type here. So yung importance factor, if you want to learn more, just click on this one. And view table of 208. So makikita natin na yung project is to carry a hazardous facility. So mathematically, ito yun, no? Type 2. So ito yung gagamitin natin na seismic importance factor. So we just need to type 1.25 plus this one and the zone factor. So for the zone factor, we have UT equal to 8 and minimize lang. And so, yung structure is to be located in Makati City. So, you can click on this one and if you're not sure saan yan, you can always communicate with Google Map. Okay? So, yan na, no? So, yan yung Makati City. So, kung titignan natin yan dito sa whole map. So, nandito siya. Ganda, no? So, nandito yan. Ganda. So, bali, dito sa CALQ Seismic, since color yung map, so, medyo halata na natin yan. No? So, nandito din yan. Makaklaro naman din dito sa map. Dito yan sa Luzon eh. So, under yan sa seismic zone 4, so we have 0.4. Okay, so let's click 0.4. So for the NV, so we can click on this one. And then we can do table now. So yung seismic source type natin is type A. And then 7.5 kilometer. So kung titignan natin yan dito sa table natin is wala tayong 7.5. So we need to perform the interpolation for seismic source A. So itong seismic source A, we have A. So per 5 we have 1.2 and for 10 kilometer we have 1.6 for 5 and 1.2 for 10 kilometer. Okay, so we have now click on this icon and let's type 7.5. So yung reference natin, meron tayong 5 and 10. And then yung NV natin is we have 1.6 and 1.2. Okay? So makikita mo yan dito na wala pang reflected na value for NV. But after we perform the calculation, by clicking this calculator icon, calculate that it is 1.4 and automatically reflected here. So close this one for NA, and to learn more, you can read this one. And then, again, wala tayong 7.5 dito. So we need to interpolate between 5 and 10. So for seismic source A, we have this one, and we have 1.2 and 1.0. So we can click on this linear interpolation and then let's click on this one. So we have 7.5 and then we have 5 and 10. And then we have NA, which is, tingnan natin yan ulit. We have 1.2 and 1.0. So we just need to type that in here. And 1.0. So, kung titignan mo yan, hindi pa siya reflected dito. So, after we click this calculator icon, it calculates the NA and it automatically reflects here in the field for NA. So, for CV naman, you can click on this one to learn more about CV, beauty ball from CP. So, yung soil profile natin is ito yan, and soil, soft rock, diba? So, which means that it is SC, no? So, click this one again. Click on this icon. Yan, makikita natin yan, no? So, yung very dense soil and soft rock is under SC. Diba? So, beauty ball. So, dito sa SC, under seismic zone 4, we have 0.56. So we just type here 0.56. Then take note it's not yet reflected, but after we click this calculator icon, it also automatically reflected here. For CE, for CE, again, can be this table since we know now na SC. So we have 0.4 of NA. So anyway, yung NA, si CALQ Seismic na yung maghanap kung ano yung binigay mong NA doon. So type mo na lang dito yung coefficient. 0.4. Minimize this one. Okay, so ano pa sobra yung minimize ko. So anyway, ulitin ko na lang. I have 0.4. With this one. Ayan. So we can minimize this one. And close this one. So for our, you can click on this folder icon. So yung material natin is concrete. So we just need to find that one here. So sabi niya, concrete moment resisting frames. So moment resisting frame under special reinforced concrete moment. Okay. The special reinforced concrete. So bali dito, we have 8.5 na factor. Use this one. Type 8.5. Minimize. And then yung CT naman. So we know this is a reinforced concrete moment resisting frame. So ito yung gagamitin natin na value. So we have 0.0731. So for minicity, dito din yan. Ito yung nakalagay sa minicity. Close this one. And then it's safe. Okay, so we can now run the analysis. Yan. So run analysis. And then let's wait for CALQ Seismic to do the calculation. Ayan na. So makikita natin dito. Ayan yung fundamental period. And then yung design earthquake based shear is 4274.6774. So kung titignan natin yan dito sa conventional, ito yan, 4274.212. So I guess due to decimal. So if you notice, meron tayong slight difference. Kasi si CALQ Seismic uses all the decimal places. Unlike dito sa conventional, kinuha ko lang is hanggang 3 decimal places lang. So for instance, if I want to have same result for this one, so pwede kong i-minimize to actually. So sabihin ko na lang na instead na up to 12 decimal places, gawin kong 3 decimal places. So change ko yan into 1.052. And let's try kung malapit pa yung design base sheet. Save natin to. And then let's click this one to perform. So pag i-click mo to, i-recompute niya yung mga values dito sa baba based on the modified value ng T mo. Ulit natin yan. And then makikita mo na meron ka na dito. So 4274.2115. So malapit lang. So ganyan. Ganyan. So now, you can now proceed in the calculation of whiplash force and the vertical distribution of lateral loads per floor level. And so ito yung conventional. And we want to calculate this one using CALQ Seismic. Ito lahat, no? So, let's say, click on this one. And, so i-reflect na automatic yung bagong earthquake-based shear and also yung modified periodic fundamental period mo, no? So, ngayon, kakalculate na lang natin yung whiplash force by clicking this calculator icon. Ipapakita niyo yung formula, no? From INICP. Then you can click calculate and you have this FT na 314.7529 which is the same, no? Dito, titignan mo. Yung sa conventional, yung whiplash force is ito yung nag-govern, no? 314.753. Okay, so dito tayo nyan. So, take note hanggang 10th floor to, no? Na level. So, let's select 10th floor level. Up to 20 floor yung kaya ng CALQ Seismic, no? So, we can click on this one and makikita mo yan. So, ngayon, dito sa ilalagay lang natin itong tabulated na values, no? Yan. So, lagay lang natin yan dito sa isa. Okay? So, I have 25, 31.5, 28, 24.5, 21, 17.5, 14, 10.5, 7. So, take note CALQ Seismic is just a calculator itself. No? So, type lang natin yan. 4,000 kilonewton. Another 4,000 kilonewton and then 3,000 kilonewton. So, once okay na tayo dyan, and so okay na din yung sa baba, no? Wala tayong mga empty cells. So, make sure na before running analysis, double check kung wala ka na yun. No? So, that's okay na, no? So, ito na yun. So, we can now run the analysis again. And just wait for CALQ Seismic to perform the calculation. And dito sa conventional, yung susolve niya is itong mga lateral load na to. Ito yung FX. So, makikita mo yan dito. So, we have calculated also the overturning moment. No? Makikita mo yan hanggang dulo. And yung lateral load. No? So, makikita mo 880.39, 678.764, and so 603.346, 527.928 hanggang dito. So, makikita mo na the same. Di ba? And also the shear. We have 880.39 up to this one. Huh? So, the same. Okay, so Ayan na. So, I hope you find CALC Seismic useful. And yeah, thank you for listening and God bless everyone. Keep safe. Cheers.